Hello, Algebra 2 students. It's Unit 4, Day 3. We're talking about geometric sequences. So we already discussed arithmetic, which meant you add from one term to get to the next. Geometric, the difference here, right, is we are going to multiply by a constant value to get from one term to the next, which essentially means that you could be dividing as well. You can think of it either way. Right? So the constant value we refer to as R, and that's referred to as the common ratio. And we'll kind of show why we use that terminology in just a second here. So the first part, when it says, is it a geometric sequence, justify your answer, you just want to check and see, can you keep multiplying by the same thing to get from one term to the next? So most of these you can kind of look at and see like, hey, times 3, times 3, times 3, and absolutely, it would keep going. So we can say yes, and the R value would be 3. For the next one, is it geometric? Well, when the sign's switching, all we're multiplying by is -1. So times -1 times -1. Again, we can say yes, the R value would be -1. In general, to find the common ratio, it'd be lovely to write down that, just look and figure it out what it is, but it's not always as easy. So if you ever can't figure out what it is, what you can think of is, if I'm multiplying by a certain number to get from here to here, then if I were to divide those two values, it should produce that common ratio. So you could take the second term and divide it by the first, or you could take the third term and divide it by the second, or in general, it would be to take a sub n and divide it by a sub n minus 1. So any term divided by the term before it, right, would give you the common ratio. So divide any term by the term before it to get R. So if you look at the top one, taking the second term dividing by the first, there was that R. Or you could take, let's say 27 divided by 9, there's that R value. All right. Same idea here. If I take -5 divided by 5, there's that -1. If we look at it, in a little expanded format down here, you have an example where it goes 2, then 8, then 32, and 128. And so you'll notice as well that geometric sequences, they get big quickly, right? Because you're multiplying, not just adding. So what I want to look at, and it's kind of drawn out for us, is how do we write a general formula based on an example, right? So if you look here, the first term's 2, so we start with 2. To get to the second term, we're multiplying by 4 in this case, so 2 times 4. And then we multiply by 4 again. Here we take that answer, multiply by 4 again. So the way you can show it is, here it's just the first term. This one is 2 times 4 to the first power, 2 times 4 to the second, 2 times 4 to the third. So what ends up happening is when you are up to something like, let's say, the fourth term, you're multiplying by whatever that, common ratio is 3 times. So that exponent is 1 less than the term number that you're looking at. If we write a definitive formula for this particular sequence, it would be that we start with 2, and then we multiply by 4 1 less time than the term number. So if we're doing a sub n, then that would be to the n minus 1 power. In terms of a recursive formula, you always have to tell me the first term, and then from there, tell me how to take the term before it to get to the next term. Well, if I wanted 128, I take the term before it and just multiply by 4. So I would take a sub n minus 1 and multiply by 4. That's it. That's all you would do to write it recursively. Can we take and extend that to a general formula? Of course. If we look here, 2 was the first term, 4 was the common ratio. So what that means is that to find a sub n, it is a sub 1 times R, and then you raise it to the n minus 1 power. And that is on your reference sheet. So that purple sheet I gave you guys, it's right on there. You do not have to memorize it. Recursive formulas are not given though. So in general, you can say, all right, the first term is whatever it is. And then to get the nth term, look at what we had here. 4 was the common ratio, so it's r and then times the term before it. I don't expect you to memorize this, but maybe you use it as a reference. If you need help figuring out, how to write something, you could come back there and take a look at it. Otherwise, let's move on to the next page. So page 10 in your packet here. So with this, just some practice. It's saying, given the first term and given the common ratio, can we write an explicit formula? Can we find a particular term? And can we write it recursively? The answer is, of course we can. So here is the explicit formula that we just wrote down that we said is on the Regents reference sheet. So good to kind of have that right there in front of you. So we're just plugging in. We're going to plug in here. We're going to plug in here. So it's 3 and then times 2 to the n minus 1 power. That's your explicit formula. To find the fifth term, an explicit formula means that you can just plug in the n value to find it. So we're going to do 3 times 2 to the 5 minus 1. Now you have to be really careful of your order of operations here. We know PEMDAS. So you want to make sure to do whatever is happening in the parenthesis first, but what's happening in the parentheses is it's getting raised to this exponent. So we need to take care of that little exponent there. So this is 3 times 2 to the 4th power. Then this goes next, parenthesis exponent. So it's 3, 2 to the 4th power. You can use your calculator if need be. That's 16. And then finally, you can do the multiplication here. If you make the mistake of multiplying 3 times 2 first and then raising it to the 4th power, you're going to get a really big number, which is incorrect. So be careful of your order of operations. So keep that PEMDAS in mind, if you will. All right, last part, represent the sequence using a recursive formula. Well, recursive formula, we said, tell me the first term and then tell me how to get to the next one. So the first term here is just simply 3. And then to get to the next one, we would say, take the term before it, so a sub n minus 1, and multiply it by that common ratio of 2. That is a recursive formula. That's it. All right, for these next ones, you've got a couple practice questions with recursive formula. And so I just want to show you how you would actually play them out by using the formula, how you can kind of play them out using that general rule of you're just taking the term before it and then multiplying or dividing from there. All right. So with this, it's telling you to get f of n. We're going to do 1/3 of f of n minus 1. So 1/3 of the term before it. Remember, that's all that means right there. And they're telling us the first term is 9. So thank you very much. So if f of 1 equals 9, then to get f of 2, remember, that means I'm putting a 2 right here. So n is equal to 2. I would do 1/3 of f of 2 minus 1, which means 1/3 of f of 1, which is just the first term. So we can take this 9 right here, and we can plug it in right there. So 1/3 of 9, that comes out to be 3. There's my second term. All right, if you keep going, the third term now, oops, I'm sorry, I was a little off the page there. The third term says do 1/3 of f of 3 minus 1 now, because the n value is now 3. So 3 minus 1. This would then 1/3 of f of 2. So here's where you need the second term to plug on in. So this is now 1/3 times just a plain old 3, because that is the second term. And then that would come out to be 1. Or if you're like, I get it. I know, just take the term before it and plug it in place of this guy right here, that 1/3, or excuse me, that f of n minus 1. So if you can make that connection, then you're just taking the last answer, dumping it in right there, and then multiplying. So this would come out as 1/3. So when it says find, the next 3 terms, you can just write them out like this. You could list them out to say, all right, it's 9, it's 3, it's 1, it's 1/3, and so on. This next one, I love this next one just because the algebra itself is sometimes something that needs to be reviewed just in general. So here it's saying to find t sub n, we're going to do the term before it, t sub n minus 1, and multiply it by radical 2. And they're starting us off with here's the first term right there. All right, so let's go. T sub 2, so I'm putting a 2 here, is t sub 2 minus 1, which is just t sub 1 times radical 2. So this time I'm kind of shortcutting my work a little bit. I don't want to show every single, substitution. All right, let's put this in now into that first spot. So we get 3 radical 2 times another radical 2. Ooh, hey, Algebra 1 skills. All right, when you multiply those together, you multiply the numbers out front together. So there's a 1 there. So that's 3. Then multiply the numbers underneath together. That's a radical 4. And then that just turns into 3 times plain old 2, because that's the square root of 4. And you get 6. Whew. All right. For the third term, t sub 3, we're going to put in t sub 3 minus 1, which is really t sub 2, and then multiply it by a radical 2. All right, take that answer, plug it in there. We get 6 times radical 2. There's nothing to be done. That's it. That's your answer. All right, you have one more. T sub 4 means that we take the term before it, which is t sub 3, and multiply it by a radical 2. Okay, plug that in there. So we get 6 radical 2 times radical 2. All right, now that we've done it once, we know how to do this. This gives us 6 radical 4. The square root of 4 turns into plain old 2, and the radical hat comes off, and our answer is 12. So the first 4 terms here are 3 radical 2, 6, 6 radical 2, 12, and it would keep on running. All right. So for those ones, it's not that you're trying to figure out the pattern. It's that you have to understand how to plug in and use the formula when written in that recursive format. Right. Next one here. It says, given 5, 15, 45, find the 7th term. Right? Now this first little hint says, first, is it even geometric? And then what's the R value? Right? Now, of course, today is our geometric sequences day, but not every day will be knowing that you're going to talk about a geometric sequence. So you want to take that quick step to say, yep, times 3. This would be times 3. So that means my R value is 3. And yes, it's geometric. Mm-hmm. So what that means is that if it fits a geometric pattern, we can write an explicit formula. And that is my goal for you. Could you write a recursive one and just keep on filling in the blanks? Yes. But I said it the other day. I don't want you to take like the, first grade approach. I want you to figure out and come up with an equation that could then find any term in the sequence. So using our new rule, it's the first term times r raised to the n minus 1. That's the explicit formula. Let's plug in for the info we have. First term is 5. The r value is 3. And then we keep the n minus 1. So now that I want the 7th term, all I have to do is plug in n equaling 7 to get the 7th term. All right. So we have 5 times 3 to the 7 minus 1. You could go right now to your calculator and type that in. If you want to clean up maybe one little piece of it and make it 5 times 3 to the 6th power. But if you type it into your calculator the way it looks, so 5 and then parentheses 3, raise it to the 6, your calculator knows order of operations. So when you do this, it's going to give you the correct answer. If you wanted to do it by hand, you'd be doing 3 to the 6th power first, and then multiplying by 5. And there you can see it's going to be that same answer there. So the first term start with 5, 15, 45. And by the 7th term, you're already up into the thousands, right? Because that's how quickly these exponential or geometric ones grow. But yes, they are exponential. We'll talk about that later. All right, let's keep moving. We got more examples to get through. Example 4. Here, let me back this up a little bit so we can see what's going on here. We've got a geometric sequence, so they're telling us it's geometric. So you either have to figure it out or you have to be told it, okay? Where the first term's 2, the 4th term is 250. Find the missing terms. We played a very similar game when we did arithmetic the other day. I want to lay it out so we can kind of see it. So the first term, f of 1, is 2. So second, third, 4th term is 250. Find the missing terms. All right. You can use the explicit formula and do this, or you can kind of set it up as just a little equation on your own. I kind of like the little equation approach, but I'll show you both. I want you to think of it, if it's geometric, we are multiplying by r to get to here, by another r to get to here, and by a third r to get to here. So we are taking 2 and then multiplying it by r, by r, by r to get up to 250. Now, of course, we'd never leave it that way. R times r times r is the same as r cubed. All right, to solve this, you'd have to get the r alone. So divide that out. This will leave us with 125. And then to undo r cubed, think about undoing r squared. You take a square root. Well, in this case, we're going to take a cube root. As a little reminder on your calculator, the cube root, I believe, is under the math key. Yeah, here it is right here. It's choice 4. So if I want to do the cube root of 125, that's going to give me my answer right there. So that would be my common ratio. So we would have to take the cube root. If you want to take any other root, like a higher root, a 4th root, or a 5th root, under the math key, you can use that xth root button. So if we get to one like that, I'll show it closer up, but otherwise just know that it's there for your reference. And now when you fill in, now that you know r is 5, 2 times 5, that would be 10. 10 times 5, that's 50. 50 times 5, yep, that checks out right there. Now, something to keep in mind, I said you could use the explicit formula. The explicit formula would be this guy, equaling a sub 1 times r to the n minus 1. What you could do is say you have the 4th term and you have the 1st term. So I want to find the r value raised to the, instead of n minus 1, think about the numbers you now have. 4 minus 1 is what would go up top. And then you could fill in the blanks. This would be 250. This is a 2 for this guy right here, times r to the 4 minus 1 is 3. You end up with the exact same equation right there. So if it helps you visually see it, you're going to set it up this way. If you're a formula kind of person, maybe this is what makes more sense. But you end up with an equivalent answer and kind of an equivalent setup, just a slightly different way to get there. All right. So with this next one, know that you have your options now. So it's saying you have the 3rd term and you have the 5th term. So again, if you're visual, maybe you're kind of setting it up to say, here's the 3rd term of 3. Here's the 5th term of 27. And then you can play it from there. Right? So if I think it'll be times r and times r, right, to get here. And I just realized it doesn't say geometric here, but I promise we're playing with a geometric setup. So since it's our notes, we can make that little adjustment there. So that means we have 3 times r times r. So times r squared equals 27. That's what's going on here. So divide by 3, r squared equals 9, and then take the square root. Now, technically, here's where sometimes we forget. I think everybody knows the answer is 3, but when we physically go in and take the square root ourselves, you actually have to remember that it's plus or minus, excuse me. So when we take the square root when solving, you need the plus or minus of that answer, because it really could have been a -3 squared that gave us 9 or a +3 squared that gave us 9. So when you go to finish the question, there's actually 2 different answers that you could end up with. So let's kind of flesh out both answers. If r is +3 versus r is -3. So over here, I'm going to rebuild what we have right there. And so the 3rd spot was 3, last was 27. 3rd is 3, last is 27. So that was our given setup. If r is just plain old 3, let's play the game of what would be next. So times 3 would be 9, times 3 is 27, that checks. If you're only going a couple terms away, I would just say, make your life easy. So if I'm going the opposite direction, now I'm going to divide by 3. That would give me 1. Divide by 3. That would give me 1/3. If the r value is -3, that just changes a little bit what you have here. So times -3, this would be -9. But then times another -3, it's still 27. So if I backtrack and divide by -3, this would be -1. Divide by -3. Oops, there we go. Sorry, I wrote that a little weird. And then this would end up as +1/3. So when the question says find r and find the 1st term, the 1st term actually comes out the same either way as a +1/3, but you do have to acknowledge that the r value can be positive or negative 3 there. So what you'll notice, it goes plus, minus, plus, minus, plus. So you're going to see alternating terms when your R value is negative. Or excuse me, I think I said you'll see alternating terms. You'll see alternating positive and negative terms when your R value is negative. So I'm going to say you'll see alternating signs. So like plus versus minus when the R value is negative. All right. So down at the bottom, I think we'll kind of finish up with this particular part, and we'll save the one on the back as a little recap and a way to start class tomorrow. So when it's saying, when given two terms in a sequence, you can write a rule or an equation using the following things. So in a sequence notation, if the fourth term, right, is given and the first term's given, like example 4 was, then we can do a sub 4 equals a sub 1 times r cubed. And so we want to keep in mind that was just 4 minus 1. Or like the second one, we could do to get from the third term to the fifth term, the exponent ended up being a 2 because that was 5 minus 3. So when it says, what should the exponent be here? Right? Well, think about what the pattern is. I'm pretty sure that you can answer that question right there. And we're going to make that the post video question, is what would that exponent right there be? Right? But in general, I'll remind you one more time that if we're given the x term and the y term, to go from the x term to the y term, you'd multiply by r and then raise to whatever that little difference is right here. Right? So don't forget to go answer that question, and then we'll save that last page for tomorrow. Thanks, guys.